Well, hello and welcome to another edition of our live Q&A sessions. My name's Sam Donaghy and I'm happy to say that tonight I'm joined by Chris Thomas from our field team. Good evening, Chris. How's your Monday been?
Evening, Sam. Very good. I'm currently out and about in the northwest at the moment.
Okay. Anything exciting?
Yeah, a good variety of visits, combination of MCS visits and going out to see some of our approved contractors later in the week as well.
Good stuff. Okay. So as before, please post your questions in the chat and we'll try and get through as many of them as we can. Same rules as always. There's no such thing as a stupid question, only stupid answers. And as always, we ask that you're always respectful when posting your help and advice to each other, as the whole purpose of the session is for the common good, in that we all learn from each other. So we'll start off with some questions. Well, we'll start off with the question of the week. So just as a reminder, the question that we posted out this week was, if an earthen conductor is not buried, can it be sized using the adiabatic equation? And we gave you some optional answers. Can you always use the adiabatic equation? Can you never use the adiabatic equation? Can you not use the adiabatic equation for special locations? And the final option was you can use it for TNS and TT earthing systems. So just a reminder again, if an earthen conductor is not buried, can it be sized using the adiabatic equation? So there's some people saying we've got a bit of echo coming through. Can we maybe turn down your end, Chris, if you've got any?
Yeah, no problem. Bear with me. There we go. How's that sound?
That's much better, I think. Much better, yeah. Thank you. Okay, so can we use the adiabatic equation to size that earthen conductor? I guess first of all we'll just, for confirmation, we'll tell people what we mean by that earthen conductor. So I'll just post up the definition. If we look in part 2 of our regs, it tells us that the earthing conductor is a protective conductor connecting the main earthing terminal of an installation to an earth electrode or to another means of earthing. And we're actually also fortunate within 7671 to have a diagram that spells out the different types of earthing and protective conductors. So we'd be looking at this conductor right down the bottom, conductor itemized number 3, which we often refer to as the incoming earth. It's the earth that we're either going to take from, for example, the DNO supplied earth, or we're going to take it from an earth electrode. So that earthing conductor, you may be more familiar with it being as termed the incoming earth. So can we size that incoming earth using the adiabatic equation? What are some thoughts around that, Chris?
Yeah, so what you mentioned about the earthing conductor, we've got to be careful with the definition of the earthing conductor. As you already touched on, Sam, a lot of people refer to it as the main earthing conductor, but as you'll be able to see in figure point 2.1 in the regs, it's the earthing conductor, which is what most people refer to as the main earth. It then links into the main parts of chapter 54, where we then got to take a look at the requirements regarding different types of earthing systems. So within that, it looks at PME earthing and then all the other typical earthing systems. We then take a look at some of the basic requirements for sizing of earthing. So table 54.1 is available to us in terms of what I tend to call a generalized approach to sizing earthing conductors. It then pushes further into the chapter and talks to us more about differences between calculating the earthen conductor and then using table 54.1. When you go through all of that, it eventually gets to the point further in the chapter where it talks to us about having to be careful using the adiabatic equation for PME. So typically it would only be in the earthing systems where we'd be looking at TNS or TT earthing systems. It's not as accurate if you were to use it for PME. So TNS, TT seems to be accurate and seems to be acceptable according to the regs, and the bulk of the explanation is found within chapter 54. There's quite a few areas of chapter 54, quite a few sections you've got to take a look at. Section typically is 3 numbers or more, but it does mention in there that PME typically is a no-no, but TNS and TT would be acceptable.
Yeah, absolutely. So if I just share with people, so this is the key regulation 542.3.1, and it says every earthen conductor, and that's what we're talking about, shall comply with section 543, which is general protective conductors, and if we look in section 543, as Chris said, we can either size things through selection using the table or through calculation using the adiabatic equation. So the first part would tend us to say, well, we can use that for the earthen conductor, but it's the second one which prohibits it. So it's the second part of that sentence which says, and where PME conditions apply, we shall meet the requirements of regulation 544, which is protective bonding. So if we've got a PME system, we need to consider it even when we're looking at that earthen conductor, that incoming earth. The sizing still has to be related to the requirements for bonding. So that will be based on the incoming neutral, and we won't be able to purely use the adiabatic equation to size that. So yeah, today's question of the week, the correct answer would have been D. We can only use the adiabatic equation if it's for TT or TNS. Always was wrong because we can't always use it. We can't use it for PME. Never was wrong because we can use it when we're not talking about PME. And not in special locations was a bit of a red herring. There was no requirement there about special locations. So just to clear it up, the correct answer should have been D. We can use the adiabatic equation to size that protective, that earthen conductor in TT and TNS systems. Okay, picking up some other questions that have been hanging over for a while. One which was a little bit of an unusual situation. What tests would need to be completed for an item of current using equipment when electrical separation is being used as the protective measure against electric shock? So electrical separation's one of our permitted protective measures, but if we are using it, what tests do we have to do to confirm that it's adequate, Chris?
So the first one, the kind of the clues in the title, really, we've got to confirm that we have achieved electrical separation, and the separation is relating to the earth, so we have to confirm that. Typically that will be done with insulation resistance tests. The values we need to obtain are the same values that we use for general testing, which is chapter 64, table 64, the minimum insulation resistance values. Then there could also be specific regulations or requirements in terms of initial verification as well. But typically the majority of it is dealt with in chapter 64. It's the name's a little bit misleading, but it's a test. So testing, particularly for initial verification, is dealt with in chapter 64.
Yeah. And I think it's fair to say sometimes people think, oh, electrical separation, that's very different. Do I need any specialist equipment? And no, you should be able to cope purely well with your standard multifunction tester, and it will be insulation resistance. We're checking that there's no connection between the live conductors of your electrically separated circuit with any of the other live conductors in the installation, and also no connection between the live conductors and earth. So yeah, it does boil down to an insulation resistance test.
Well, for some of our older contractors, they might want to use the old windy up megas, Sam.
Yes, and get the apprentices to stand in a circle and hold. Yeah, that. Well, we won't go there. We won't go there.
Well,
but yeah,
make sure it's accurate as well. Make sure it's got current accuracy checks as well.
Yeah, it's actually interesting because a subject that we were talking to with somebody else was, and I'm sure it's something we'll come back to, is we've got installations at the moment where sometimes we do use voltages greater than 1,000 volts. So in particular in the PV world, where we've got a large array, we might have cables that are carrying 1,500 volts, 1,500. So it still falls within the scheme of BS 7671. But currently 7671 just talks about insulation resistance testing up to 1,000 volts. So that was what made me think about the old machines, which, you know, currently my MFT only goes up to 1,000 volts. But yeah, there are proprietary test equipment that goes higher. So yeah, good point.
Yeah.
Another one, which is, again, it's a fairly common question. Can I use a building's lift shaft to route cables between floors? So this is the age-old question of, there's a fantastic cable route already within the building, but can I use it to route cables?
No, definitely not. This is one that for some reason always sticks in my head. I remember when NIC published the, going back to the 17th edition, the presentations for that in the training packs that we give out. And I actually remember this slide vividly. You can only use the lift shaft or the elevator shaft, depends which way you look at it, for the associated equipment, which basically is normally the hoist and the control gear for the lift. So the quick answer is no. And there's also quite a lot of detail within that. 52835 deals with that in terms of the cabling, and there's also safety rules as well, which are a little non-standard. BSEN 81, which deals with safety rules for construction and installation for lifts.
Yeah, so it's one of those ones that's specifically excluded, isn't it? It's absolutely prohibited. There's a reg that says we can't do it, and it's really around the potential danger of that lift service that it could have on the electrical installation. So yeah, it's a real no.
Yeah, we understand why people tend to look at it as a perfect transit system for the wiring system, but it specifically forbids it in the wiring regulations.
Yeah. Another common one, what's the minimum height for a socket outlet above a kitchen worktop in order to comply with 7671? So yeah, any minimum heights above surfaces for socket outlets?
I think we still advise 100 mil, isn't it, Sam?
Yeah,
100 mil. I mean, there is no specific requirement as such, not from a regulation point of view. I mean, this is where an individual's electrical competency comes in to identify any potential external influences, and then you would keep it an appropriate distance. The best thing to do in this situation is to use best practice guides produced by us or others, which will advise but not determine the minimum requirement. It's just advice and guidance. But if you think it's not suitable or there's real danger which could occur from that, then increase the distance if necessary. But we get similar questions, don't we, regarding distances to socket outlets and switchgear near sinks, don't we? This is kind of related to that, where what's the minimum distance? Again, we get best practice guides, but there's no minimum requirement as such which is stated.
Yeah, absolutely. There's no definition of distance within 7671. When it comes to height above surfaces, there is actually a regulation, but it talks about ensuring that the risk of mechanical damage to the socket or the plug and its flexible cable is either during use or when the plug is withdrawn is minimized. So it's telling us what we need to achieve, and it's one of those situations where, because there's multiple ways of achieving it, it's not specific as to which one. So yeah, it is an engineering judgment, and we give some guidance based on a sort of a generic socket outlet and a generic plug type, and we're estimating the curvature of the flex required coming out of the bottom of the plug. You know, we would suggest 100 mil from the bottom of the socket outlet to the worktop or surface, just to give enough distance for that cable to flex. What we don't want is to put strain on the cable, strain on its connections, or strain on the plug itself, so it doesn't actually make a true connection with the socket outlet. So a bit of a judgment, but as a recommended guide, we would suggest 100 mil minimum.
Yeah, you don't want a hard right angle for it, which you see in some situations. That's going to put a lot of strain on the cable.
Yeah, and we got asked the question quite a lot, and some instances it may be that it's a void property or a new build, and therefore there will be nothing plugged in for you to sort of see the way that it's going to be used. So then it would be a generic guide, but obviously if it is an existing property, then you can actually have a look at what appliances are plugged in to see if it is causing any issues.
Absolutely.
We've got another one on cables, a bit of a change this time. So is there a maximum length for caravan hookup cables to supply caravans in a caravan park? So I think we're talking about the lead that's going to go from the hookup point to the caravan itself. Any maximum distances for that lead?
Yes, so well, it depends which distance. So if you're looking at distance from the pitch to the caravan, typically that's 20 metres as stated in section 708. The lead itself typically will be, remember rightly, 25 metres plus or minus 2 metres, I think is the exact statement in there. So you've got to allow for, very similar to the last question, where we've got to allow for some flexibility within the cable. The usual suspects really from the cable point of view: make sure it doesn't present a tripping hazard, make sure it's not going to come under any stress or damage, and obviously overhead wiring systems, if applicable, can also present a unique challenge as well, where there are minimum distances quoted within the standard. But typically if it's just a trailing lead from the pitch, 20 metre distance up to the pitch, and then 25 metres plus or minus 2 metres for the lead itself.
Yeah. So there's a regulation, isn't there, in section 708 that tells us that it should be designed such that the hookup point and the electrical equipment to which you're going to be connected should be no more than 20 metres physical distance. So that gives us a guide that they're trying to minimise the length of that cable to reduce the issues that you might get with the cable and its environment, and the potential for it to be frequently disconnected and connected, which means that it's going to get some quite rigorous use.
Absolutely.
Okay, let's take some. So if we look at our questions coming in tonight now, first one up, evening. What code on an EICR for a rental property with no CPC on the lighting circuit? Owner doesn't want to rewire lighting circuits. Is it okay to replace all light fittings with class 2 insulated light fittings? What's your thoughts on that? First of all, code for on an EICR for no CPC on the lighting circuit?
There's a question mentioned whether the class 2 is already in place or he's going to change it.
Well, it raises a question in itself, because I think the suggestion is the owner not wanting to rewire the lighting circuit. Is it okay to replace all light fittings with class 2 insulated light fittings? So at the moment it would appear that we've got some class 1 light fittings. Also, we've not mentioned the switches, which would obviously be accessible and would need to be considered as well. So what's your thoughts along that? Let's say there are some class 1 fittings. What code would we give?
So it's got potential for danger. I mean, in my mind's boggling at the moment. I've got more questions I want to ask and what I want to validate. But it wouldn't be C3, assuming there's class 1 in place already, because with C3, if you left that in place, that implies that it's a nice record, it's a nice improvement to have, but it wouldn't be dangerous. In my opinion, it potentially could be. So a minimum of C2, and depending upon what state the earthing system is, potentially C1. It really depends upon what does it mention the state of the earthing at the moment, Sam?
No, it doesn't, and so that would be another thing. Are we thinking about RCDs just for additional protection, or are they required for fault protection? Because, for example, it's a TT installation. So let's. I know it's a big assumption, but if we assume it's a typical domestic and it's not TT. I think we'd go C2 if it's got class 1 fittings without a CPC. If we were able to change all of the accessible class 1 fittings for class 2 fittings, but that would need to include the switches as well, not just the light fittings. Would we be able to take that C2 down to a C3 if we add all class 2 fittings?
Yeah, I mean, again, the mind's boggling with lots of other questions, but trying not to make a big meal of it. Then, yeah, if that was the case, and we could guarantee all extraneous or exposed conducted parts have been swapped for a class 2, then, yeah, we could, in theory, downgrade that to C3. But see, the thing is, from experience, if it's not got that in place, it tends to mean that there could be other problems as well. So I'm trying to resist going into it deeper, but it's indicative of other problems to me.
Yeah, and I think even if we were to take it to a C3 by fitting class 2 fittings, we'd also recommend a label at the board to make people aware that there's a reason why those fittings have been changed, and not to change them back. So that would need to be it would be a strong recommendation to add that as well, and also always a recommendation to provide enhanced protection. Obviously, if we had a CPC and we had RCD protection, it would give them some advantages. So it's one of these ones where it would be a strong recommendation, not a requirement under 7671 for an existing installation, but certainly a strong recommendation.
Yeah, that's the assumption. It's before additional protection become a requirement on lighting.
Yeah. Okay, another one. With the advent of metal consumer units, is there a requirement to fit metal board blanks? And the engineers said, personally, I think they're a danger, as they often tumble out when removing board covers when testing, and fold short out and can short out between bus bar and casing, because obviously being metallic, they're conductive. So is there a requirement to fit metal board blanks? I think it would be very much based on manufacturer's instructions for the installation. So if we've we need to achieve that non-combustibility. If the manufacturer insists on a type of blank in order to achieve that, then we would need to consider, and unless we've got very strong reasons why not, go with that recommendation. There's nothing that says specifically it has to be metal blanks, but it would need confirmation from the consumer unit or distribution board manufacturer, to confirm that they'd still be compliant with that requirement for non-combustibility, depending upon the type of blanks that were fitted.
Definitely.
Okay, another one that's come in. Please clarify when fire clips are supposed to be used in a domestic dwelling. So what's our requirement for fire clips, Chris?
So anywhere where we suspect that we're going to have premature collapse of the wiring system, obviously, although it's no longer focused just on escape routes, obviously we'd be very mindful of escape routes as well. But basically, the requirement in the regs now under Chapter 42 is that anywhere where we could have premature collapse of the wiring system, we need to ensure that it's adequately supported. So the clip is a good way of doing that, but if you read the reg, it doesn't actually state you have to use clips. It's just a good way of achieving that. If there's no chance in the practical world that the wiring system is going to drop, then you don't necessarily have to use clips, but it's obviously a really good way of achieving that if you want to make sure that it's not going to be prematurely collapsing on people's heads as they're trying to evacuate the building.
Yeah, and you know, get some guidance from the cable manufacturer based on the size, the cross-sectional area and weight and length of run in terms of minimum distances to put fittings. In some instances it might be the situation where you know, you might be able to intersperse the metal fittings that are preventing premature collapse with standard fittings, for want of a better phrase. So it's possible, depending upon how close together we're putting them, that you may not need all fixings to be, but as you say, certainly the key is to prevent premature collapse, and we're talking about things that would then prevent evacuation from the building, and also put any people who might be entering the building, such as firefighters, at a risk during that point of premature collapse. So before sort of the fire degradation, the structure of the building starts to collapse, we don't want the cables to form issues with either people evacuating or people coming in to help with the evacuation or fight the fire.
Absolutely.
But as you rightly say, even in dwellings now, the requirement was enhanced, so we removed that wording about escape routes. It's now everywhere, so you know, you would definitely be thinking about doorways. You've perhaps even got to think about areas of rooms. If we've got cabling below, for example, in a domestic, the plasterboard ceiling. You know, quite often in particularly in some social housing and council buildings, we get mini trunking used because it then makes it easier to rewire, so we need to consider it there.
Absolutely.
Okay, another one we've got, I think, is a comment back to the engineer who asked the question about the blanks. So we've got, if you replace a consumer unit in a dwelling that has 6mm twin and earth running through the loft in 101, are you required to upgrade the cable on circuit? So let me just read that one again. If you replace a consumer unit in a dwelling that has 6mm twin and earth running through the loft, and it's he's put that it's installation method 101, are you required to upgrade the cable in the circuit? I think we'd need some more information there. Obviously, covering it in insulation has a detrimental effect to the current carrying capacity, so you would need to look at just how much installation method 101 brings down the current carrying capacity to see if it's still adequate. We don't really know what the 6mm cable is doing, but obviously that insulation is going to have a detrimental effect and reduce its safe current carrying capacity. So yeah, you would certainly need to consider it. If you're replacing the consumer unit and that cable's already there and existing, it's not actually your responsibility, but you might have to consider it when you think about, is it safe to re-energize that circuit? So for example, if it is carrying a large current and it's showing signs of thermal damage because the insulation is preventing it from cooling, then you would need to consider whether you feel it's safe or not to energize that circuit. So it's possible, if you wanted, if the homeowner wanted you to re-energize that circuit, that you might have to rewire, or at least perhaps reroute the cable so it's not affected by the insulation. Any other thoughts on that one, Chris?
Yeah, from the word go, I get what the engineer means by replacing the consumer unit. So I think what he's asking is, it's an existing circuit, but he's updating the consumer unit. So does he then take responsibility for that? I mean, my opinion on it, again, there's other facts I would need to know, but my opinion on it would be that, the fact that you're replacing the consumer unit, is the assumption is you're upgrading it from an old rewirable fuse board, then it's obviously going to be a remarkable improvement on the existing board. You could then take a look at obviously any signs for thermal damage, as you mentioned already, Sam, and then you could go a step further than that just to demonstrate that if you were to start looking at the circuit itself, you could go further. You could start looking at your derating factors. Table 52.2, looking at the thermal insulation deratings, and then obviously we're going to apply that to our overall rating factors. But the point you mentioned about what it connected to, at some point we need to know, because we need to be able to work out the tabulated current and work out the derating from there, whether the cable needs to be upgraded or not.
Yeah, and I think one of the other engineers has come back with something similar. It depends on what it's feeding and the outcome of the cable calc, and whether it's showing any signs of thermal damage. So yeah, a little bit of a question to confirm whether it's safe for continued use. But I think the other issue that might be being highlighted is, as it's an existing installation, as it's an existing circuit, does it become their responsibility? Well, no, but you'd need to make that clear. So on your installation certificate, perhaps you're going to record something along the lines of consumer unit changed, with a test for electrical safety only of existing circuits. So that way you're making it clear that all of those circuits that you've reconnected were there already. You haven't installed them, you haven't inspected them throughout their length, but you've done reasonable tests to ensure that they're safe to energise and safe for continued use.
And speaking of one of those points, Sam, one of the common things I see when I'm going out to see the contractors to do assessment visits is the extent of the installation covered by the report. A lot of guys, it's very common for them to put full rewire or all. In this situation in particular, you need to be, as you said, you need to be very specific on what you're covering and any explanations of any, for want of a better phrase, unusual situations.
Yeah, absolutely, because it's very easy to mistakenly take responsibility for everything, I should say, for everything. So yeah, this is where you want some nice detail in the extent of work covered by your certificate, and if needs be, exclude things within that. So it's making it very clear at a later date. We've all been places where we've done something, and then at a later date we get accused of painting the walls, fitting the windows, everything, and all we came to do was change a socket front. So yeah, be as detailed as possible on that installation certificate. I think the engineers come back with a comment about the safety clips. So he said, I had a recent audit by OLEV on one of our EV chargers. The SWA was 5 meters in length and cable clipped in a garage at low level along one wall. They picked up on having no fire clips. It's possible. It really does depend on if it's low level and against the wall. Could that, if it came away and then was on the floor, could that create a hazard for somebody looking to evacuate that area? So no cast iron ones. It would be a risk-based assessment based on the probability of that causing a hazard to people trying to evacuate or enter. Another common one, is it permissible to through crimp and heat shrink, or MF junction box, so that's maintenance free junction box, and plaster over if somebody damages a cable? If not able to, or the client doesn't want the whole wall chasing out or flooring inaccessible. So let's take that in two bits. Can we use multifunction junction boxes and plaster over them to do a repair on a damaged cable?
Did they say that's maintenance free?
Yes, yeah,
Sam?
yeah. So that was
So,
they gave us two scenarios, and I think we'll treat them separately. So the first one, yeah, if it's a maintenance free junction box, so it will have the right symbol on the front and be to the right British standard. What's our thoughts?
yeah, so maintenance free would be fine. If it's got the terminals we need to access to, then it wouldn't be. We'd still need a hatch of some description, but if it's maintenance free, then it's designed for that use, so that would be fine. It's not ideal, obviously, joining cables together, but if it's done correctly and you can either access it for non-maintenance free, or you don't need to access it for maintenance free, or if you have to access it for the maintained connections, then it would be fine. It's not ideal. It's not as good as a continuous cable, but it would be acceptable.
Yeah, yeah, and so maintenance free are one of those connection types which don't need to be accessible for future maintenance and test. The other option that was talked about was crimping and heat shrink. Now, crimping is also an acceptable method of connection which doesn't need to be accessible for test and maintenance, but my concern would be over heat shrinking. Heat shrinking isn't really there to give it mechanical protection, so you may need to consider putting that crimped connection in an enclosure of some sort, because typically to get at a crimp you need to strip the cable down to a single layer of insulation. It's then very difficult to not make any of that single layer of insulation exposed, so you might need to think about additional type of a small enclosure of some sort, just to give the crimped connection that additional mechanical protection.
Label the enclosure as well, so that anybody at a glance knows what it's for if it's ever encountered as part of the wiring system.
Yeah. Okay, another one we've got coming. Can I put LED strip drivers in same hole cut out for downlighters, or do we need a hatch for access? Note we have 6 number transformers in the ceiling void, so 6 of transformers in the ceiling void. So let's just have a read of that again. Can I put LED strip drivers in the same hole cut out for downlighters, or do we need a hatch for access? Note. So if we're saying, I'm reading it one way, is can I put the drivers in the ceiling void above the or in close proximity to the hole that I've used for the downlighter itself? And you would need to get confirmation from the manufacturer of the drivers, and again we've got to make sure that the cables entering and exiting the driver are suitable for that type of location. So you'd typically be thinking of sheathed cables, so again we wouldn't recommend having single layers of insulation exposed. But it's possible, but you would need to get confirmation, because there may be heat sink issues, so you want to give the manufacturer some information about just how big that ceiling void is. Again, as we mentioned with one of the earlier questions, you're going to have to think about is it going to be covered in insulation, which again the manufacturer of the drivers may not recommend or even prohibit. So it's possible that I can't think of anything that stands out that says you can't put the drivers in the ceiling void. Again, so ultimately the connections will be accessible. It would mean removing the downlight to get access to them, but that's accessible because the downlights are clipped so that they can be removed. So it's possible, but you just would need to make sure that it's suitable for that environment based on the conditions above the ceiling void.
Yeah, avoidance of thermal buildup as well, Sam, so that's where you need to check with the manufacturer. I know it seems a bit of a cop-out sometimes asking the manufacturer, but they know the equipment better than what the regs does. So sometimes we have to ask the manufacturer.
Yeah, I've seen it where they're quite common, that they'll tell you, they must be installed this way up, and the void that they're installed in must have this amount of space all the way round, because they will want to get rid of some excess heat. And so providing that void will give them the dimensions required, it's certainly possible. Okay, we're running towards the end. We'll just finish with another one on extra low voltage lighting. Table 52.3, that's in 7671, states that the minimum cross-sectional area for the conductors of a sheath cable used for lighting is 1 mil squared. So yes, there is a table that tells us minimum cross-sectional areas for different types of applications, and for lighting we've got 1 mil. Is there any allowance for extra low voltage lighting installations using LED fittings? So what's your thoughts on that, Chris? Can we ever go below 1 mil for extra low voltage lighting?
Yes, I mean, there's a couple of things that spring to mind. The same area of the regs you mentioned a moment ago, Sam, Chapter 52 has some exemptions there with respect to extra low voltage lighting. 5241 springs to mind. Kind of similar to the last question we looked at, which is manufacturers should also be consulted as well, just in case there's any specific requirements there. There is also, with respect to special locations, so we've got 715, which on the grand scale of things is a relatively new relatively new section of the regs, and that covers ELV for special locations, so that will be worthy of note, and that has some exemptions there as well.
Yeah, so it's one of those ones in the reg which actually introduces us to table 52.3. The regulation itself says that there is a permitted exception for extra low voltage, and then, as you rightly say, Chris, if we go to section 715, there's a reg that tells us that the minimum cross-sectional area for ELV conductors can be determined based on load characteristics. So obviously with extra low voltage we tend to have a much more reduced current, so we can use smaller cables. The only thing we have to be aware of, if the cable is also being used to support the light fitting, then there's a minimum of 4 mil. But if we're just running cables to extra low voltage fittings, then we can use cables smaller than 1 mil, providing that they're capable of carrying the required current.
Yeah, the reg number as well, Sam, 715524201. The 201, to cast anyone's minds back to their regs courses, is specific to the UK only, with it being 201.
Okay. Right, once again, it's always the fastest half an hour of my life. We'll just talk about there are no more Wednesday webinars. We completed this year's Wednesday webinar series last week with a webinar on the subject of the most common complaints which our customer relations team receive. So I want to remind you that you can watch that and all other webinars that we've produced from this year by visiting the NIC website and going to the on-demand section. So I've just posted some information up on the screen about some of the previous ones, and you've basically got the whole year's worth of webinars that are available to watch on demand. We do have, although there's no Wednesday webinar next week, we have one more live Q&A session this year. That will be on Monday the 20th of December at 8 p.m. So if you can, please join us for that session, and we'll try and round off the year as best we can, and again try and answer any of your questions that we've got. So really just to say thank you very much for your attendance, and certainly for posting your questions. I hope we've got round to yours. If we didn't, we'll put them in the bag for next time, so that we get to start off the session on the 20th with those questions that we didn't get round to this week. But if not, I do apologise, but we will get to them. We don't throw them away and forget about them. So yeah, I hope you've enjoyed it. Thanks very much for your support to each other again. It's always appreciated. Thanks, Chris, also as well. It's good. It's one of those. So at one time in the old days, me and Chris were in the same office, but we nobody goes to offices anymore. We don't see each other. I think the last time before tonight, when I was looking back, I spoke to Chris was August. So yeah, it's amazing how quickly things go. Any last words from you, Chris?
Just everybody just stay safe and watch what you're doing out there when you're working hard, and hopefully everybody will have a good Christmas break, because I think everybody's been working very hard out there from what I see out there.
Yeah, I think that's very true. We got we got the real impression that after the first series of lockdowns, when it went extremely quiet, people were then first of all playing catch-up mode, and then obviously people not turning work down because they never knew when it was going to stop, and also one of the things with people being at home, it's actually introduced a lot more domestic work. So we've got a lot of people wanting home offices. We've got a lot of people turning small outbuildings into home offices. So there's actually been a spike in work, and long may that continue, but yeah, don't forget you do need a break every now and again.
Absolutely.
Okay, well, we'll leave you with just a reminder of the next one in a fortnight's time, and on behalf of Chris, myself and Searchall, thanks very much for taking the time to watch and join in tonight, and thanks very much for your questions, and hope to see you again soon.
Thanks guys, stay safe.